and welcome back to Algebra 1. Our goal for today is to start to look at a special type of inequality called a compound inequality. We're going to start by looking at how to create the graphs of the solutions of these compound inequalities, and we're also going to add in a third way to represent our solutions of inequalities, which is what's called an interval notation. Because at this point, we should be able to identify our solutions as an inequality statement, like x is less than something, or x is greater than something, or x is less than or equal to something, or x is greater than or equal to something. We should be able to identify our solutions in a picture or a graph format where we color or shade in our solutions. So we're going to add in that third type of way to show all of our solutions, which is called an interval notation. Some things you need to keep in mind when writing an interval notation to represent solutions. Your first thing is your first number. It's going to end up sort of looking like an ordered pair where you use either parentheses or brackets. A parenthesis shows that you would have a starting location, but it's not part of the solutions. Like an open circle would mean I use a parenthesis. Whenever I have a value of infinity or negative infinity, I also have to use a parenthesis because those are unattainable, unreachable values that we'll never actually get to. So we can't actually ever get to that value of infinity or negative infinity. So those need parentheses, not brackets. A bracket would represent a number that is included in our solutions. So the way that interval notation works is your first number inside your interval represents your beginning portion of your solutions, or what's the smallest value of your solution set. And then your final value of your interval notation represents that last value of your solution set. Some of these interval notations will include unions and intersections of shading or solutions, and you'll have to use some symbols down there which look like a U or an upside down U. So more specifically, that bottom one where it's a U shape, that says that we have a couple different sets of shading, and so we need to say it starts at one spot, ends at one spot, but then it restarts at another spot and ends at another spot, where you would have to include that U-shaped or union symbol in between your sets. So let's start with our most basic inequalities, which we should already know how to graph and color our solutions. So option one, right, we have three ways to express our solutions here. So option one is to write our statement as an inequality statement like I have there. M is every number less than negative 3. Option number two, which we should already know, is to make our picture of our solutions. We're going to put our negative 3 on our number line. I've been asking you to show two numbers on each side of that. So negative 4, negative 5 getting smaller, negative 2 and negative 1 getting bigger. Since negative 3 is not a solution, we would start with an open circle and we would shade everything less than all the way to negative infinity. So the way that we get our interval notation now from either our inequality statement, or it's a little bit easier from our picture, is we need to think about what's our smallest thing that we colored all the way to our biggest thing that we colored in. So technically, this arrow points that we went all the way to negative infinity. So our smallest value that we colored in as a solution was negative infinity. That's the beginning of our interval. So what goes over here in this last little block? I'm going to make a little bit bigger down here, just so you have an easier time seeing it. Since we can never actually reach or obtain the value of infinity or negative infinity, we have to start here with a parenthesis, not a bracket. So just be careful. So our smallest value would be negative infinity. And then our second value in our interval is our highest or largest value. In this case, our final place of shading. So our final place of shading was here at this negative 3. However, negative 3 was not a solution. So again, it's going to use a parenthesis here, not a bracket. And so our interval for this one would be our solutions go from negative infinity to negative 3, where both the negative infinity and negative 3 are not parts of the solution. So parentheses, not brackets. All right, let's try another one. 19 is less than or equal to G. My suggestion, there's still quite a few of you messing up your graph when you don't have that variable first order. So my suggestion would be put your G in front, your 19 in back, and make sure you flip-flop so that your statement means the same thing. Because both of those statements, both of those inequalities have the same exact graph, and they both get shaded to the right, so be careful. So 19 in the middle, 20 and 21 getting bigger, 18 and 17 getting smaller. I'm going to start here at 19, It is a solution, so we need to color it in. It could be equal to 19. And then we have to shade everything greater than 19, which would be our 20, 21, 22, 23, and so on, all the way to positive infinity. All right, so again, for your interval notation that goes back here, we need to start with our lowest solution and go until our highest solution. So the first value we colored here was actually this 19, right? That now is our smallest or our lowest value. It is part of our solutions. It could be equal to 19. So this is going to get a bracket here instead of a parenthesis. If that was an open circle, it would be a parenthesis. So you have to be careful there. All right, and then our final thing that we colored in as a solution, right? If we follow our solutions here, they technically keep going all the way to positive infinity, which we just show with our infinity sign, which is sort of sideways figure 8. Now again, infinity and negative infinity are unattainable, unreachable values, so this has to be a parenthesis, not a bracket. Even though it looks like we sort of shaded it in our picture, we never actually get there, so it is a parenthesis. All right, number 3, h is every number less than or equal to negative 80. It's already in variable first order, so I don't need to do any flip-flopping here to help us with our coloring of our solution. So option 1, we can represent our answer as an inequality statement of h is every number less than or equal to negative 80. Option number 2, we can make a picture of our solutions in a graph on a number line. In this case, negative 80 is a solution, so we would start here at negative 80 with a closed-in circle. And then we want everything less than or equal to. So everything less than would be all the way until negative infinity. All right, so our interval notation, our smallest, lowest solution, right? We follow our shading all the way to the end. Our smallest solution here is a negative infinity. For infinity and negative infinity, we can never actually reach there, so a parenthesis, not a bracket. All right, our ending part of our solutions is at the value negative 80. So our upper end here of our interval is at negative 80. Since negative 80 is a solution, it's colored in, then we have to include it down here. And the way that we show we include it is a bracket instead of a parenthesis. I want to show all our solutions of the value k is every number greater than negative 2 as an inequality statement, a picture of our graph, and in our interval notation. All right, our inequality statement is k is every number greater than negative 2. Our graph would be an open circle at negative 2, and everything greater than would be to the right, which means our interval starts at negative 2 and ends at infinity. Since negative 2 is an open circle, we have a parenthesis here to start. And infinity and negative infinity, we can never actually reach. We'll always get a parenthesis. So our interval here would go from negative 2 to infinity, not including the negative 2 and infinity. All right, in your notebook, try the 7. Try to make the inequality statement, the graph, and the interval notation. Hit pause here and try to see if you can get the correct interval notations to match your solutions. All right, hopefully at this point you have your graphs of your solutions, so let's look at them. All right, for t is every number greater than or equal to 10, we should have a closed-in circle and a shade to the right. And our interval should be from 10 to infinity, a bracket on the side with 10 because it's included, and a parenthesis on the side with the infinity. All right, number 2, h is every number less than negative 41. We should have an open circle and a shade to the left. Our lowest solution would be at negative infinity, our highest up to negative 41. Both negative infinity and negative 41 should have parentheses with them, not brackets. So be careful with your interval notation. All right, negative 6 is greater than g. I would take the time. G then is less than negative 6 is the other way to write that. That helps us a little bit more with our picture of our solutions. We should have an open circle here, and we should be shading to the left. If you accidentally have an open circle and shade to the right, your number line, your picture version is wrong, and your interval will be wrong, so be careful because our solutions here go from negative infinity to negative 6, and we should have parentheses, not brackets, because the negative 6 is not a solution. All right, m is every number greater than negative 11. We should have an open circle and a shade to the right, which means our interval will be from negative 11 to infinity. Again, we have an open circle here where negative 11 is not part of the solution, so a parenthesis there, not a bracket. All right, p is every number less than or equal to negative 34. We should have a closed-in circle and a shade to the left, which means our interval starts at negative infinity and goes to 34. And we should have a bracket on the side with 34 because 34 is part of our solution. So to show that it's included, we change that parenthesis to a bracket. All right, w is every number greater than 0. We should have an open circle at 0 and a shade to the right, which means our interval will go from 0 to infinity. And both of those should have parentheses because the 0 is not part of our solutions. It's an open circle, which means it stays as a parenthesis in our interval notation. All right, negative 9 is greater than or equal to k. Again, I would take the time to say then that means k is less than or equal to negative 9. Both of those give you the same graph of solution of a closed-in circle and a shade to the left. So even if you're not going to take the time to flip-flop the order, you need to have the same exact graph of solution. So be careful. Which means our interval goes from negative infinity to negative 9. Not negative 9 to infinity, so be careful. The negative 9 is the solution, so that part of our interval needs to be a bracket, not a parenthesis. All right, so our goal for today is, can we look at how to write an inequality statement, make a graph of a solution, and write our interval notation for what are called compound inequalities, or what are known as and or inequalities. So we're going to start with our ands. So our rule for an and compound inequality is that it represents what's called an intersection relationship. And an intersection relationship just means where do my solutions overlap with one another. So when we're done with an and, when we're done solving it, or we're given an and inequality statement, we only keep the solutions where they're on top of each other, right? Because these are going to really be like two inequalities within one. So my suggestion whenever you have an and inequality is to make a scratch paper sketch of your solutions for each part of the inequality, and then you have to find where they overlap, where they're on top of each other. That's the portion you keep for your final answer only. So I'm going to have like a piece of scratch paper off to the side for right now. I'm going to make like a little scratch version, and then I'm going to make my final. What are the only things I'm going to show for my final version when it's an and? So if we have something that looks like this, negative 2 is less than or equal to x, which is less than 10. That represents what's called an and inequality, right? It's both negative 2 is less than or equal to x and less than 10. All right, so this statement here is our inequality statement. So negative 2 is less than or equal to x, which is less than 10. We want to try to make our graph, our final version of our graph. Keeping in mind that's really sort of two inequality statements have been smushed into one big one. So let's think about them individually first, because we need to keep only the part where they overlap or are on top of each other. So we're going to go to our scratch paper. Let's make our little sketch here. We have two problems here. Negative 2 is less than or equal to x, and x is less than 10, right? And the and just sort of smushed those two things together. So the way that our number lines are going to change a little bit here, since we now have two values instead of just one, I'm going to use my two tick marks that are offset from the center. So negative 2 here and a 10 here. That's what I'm going to ask you to show. And then I'm going to think about my types of circles and make a sketch of where those would shape. So for this one here, negative 2 is less than or equal to x. Remember, that's the same as saying x is greater than or equal to negative 2. So it would start here with a closed-in circle, and we would end up shading this direction. Now, keep in mind, this is just our rough sketch so far. All right, now we want to do that same thing for our x is less than 10, right, which would start here with an open circle, and it would shade this direction forever. Now, for an and, you only keep the part where they overlap one another. So there's three sections here. There's this less than negative 2 section, there's this middle section, and there's this greater than 10 section. only one of those three sections in this case has both shading, right? This section only got one shading. This section over here only got one shading. And this middle section is where they're on top of each other. That's your final you would keep for an and. Where do they overlap, or where are they on top of each other? So our final graph would look like this. I have a -2 with a closed-in circle. I have a 10 with an open circle. And our shading should go in between only. And I'm not allowed to keep any of the other shading because we're only keeping the portion where they overlap when it's an and. All right, we want to write our interval. Our lowest solution starts at -10 and our highest one stops, -2, and our highest one stops at +10. So we go from -2 to 10. Since -2 is a closed-in circle, this side is a bracket. And since 10 is an open circle, this will be a parenthesis, so be careful. All right, number 2, we want to graph the and compound inequality of -10 is less than x, which is less than or equal to 20. All right, that's our inequality statement. Let's go make our rough draft, right? Break it apart. We have -10 is less than x, which is the same as saying x is greater than -10. And we have x is less than or equal to 20. Let's graph them and find where they overlap with one another. So we have -10 here with an open circle, and it would shade this direction. I'll go ahead and change my pen color here. That might help us a little bit. All right, our second one starts here at 20 with a closed-in circle, and less than would take us to the left, right? So this one's going to go this direction. And we only keep the part where we have both red and green, right? Where they overlap with one another. So this part here is just green. This part here is just red. This middle part has both. That's the section we would keep for our final version. So when we go back to do our final version, we have a -10. We have a 20. An open circle at -10. A closed-in one at 20. And where they overlapped is what I keep for the final and, which is in between. All right, our interval then starts at -10 and ends at 20. At -10, it's not a solution, it's an open circle, so that's a parenthesis. But at 20, it's a closed-in circle, it is a solution, so that side has to be a bracket. All right, number 3. All right, you need to be careful here. My suggestion to you would be to get that into less than order. 72 is greater than or equal to x, which is greater than 51. Right? If I do my flip-flopping to get it to less than, I have a 51 is less than x, which is less than or equal to 72. Now, I don't have to do that. Both of those inequality statements are going to give me the same exact graph. But now I'm in the order that would match my number line, right? This smaller number is going to be the 51. This bigger one is the 72. Please do not put the 72 down there and the 51 up there. You have to number your number line correctly, so be careful. All right, so we have 2 statements here. 51 is less than x, which means x is greater than 51, right? Those are the same thing. And x is less than or equal to 72. All right, so we have an open circle here at 51, and we should be shading for it to the right. We'd have a closed-in circle for 72, and for that one, we would be shading to the left. Again, this middle section is where they overlap with one another, which would create our final graph, because for ands, we only keep the intersection, which means we only keep where they're on top of each other or where they overlap. So open circle at 51, closed-in circle at 72, and a shade in between. Which means our interval will start at 51, end at 72. Open circle at 51 means a parenthesis. Closed in at 72 means we would have a bracket because we need to include it. All right, second type, what's called an OR compound inequality. This special inequality represents what's called a union relationship, which a union just means I'm gathering all of the solutions and I'm keeping them all, which means everything I ever shade for any of the inequalities stays in my final answer. It stays in my final graph. So So I don't need a scratch paper here because I'm going to shade for both, and I'm keeping everything I ever color in. It's going to make writing our intervals a little bit more complex. Remember, our union relationship would be that letter U in our interval if we need it. So we want to graph our solutions to the inequality statement of x can be every number less than 4, but it could also be every number greater than or equal to 6. Right? That's our inequality statement. I don't need scratch here because I'm going to keep every part I ever color for x is less than 4 and every part I color for x is greater than or equal to 6. All right, 4 is our smaller number. It should be down to here to the left. 6 is our bigger one. It's going to be up here to the right. All right, open circle at 4, and less than means I'll end up shading to the left, all the way to negative infinity. I don't need to do any scratch because I'm keeping that whole entire section. All right, x is greater than or equal to 6 will be a closed-in circle and a shade to the right. Again, I don't need to do scratch because I'm keeping everything when it's an or compound inequality. Now, here's where things get a little bit tricky with our interval. We now have 2 sections of solutions, which means we're going to actually describe 2 separate intervals, and it's a union of those 2 intervals. So I'm going to have an interval, a union, and an interval. So our first one, our lowest possible solution here is negative infinity. So I have to start there. So from negative infinity up until positive 4, and it should be parentheses on both sides there because the circle is open at 4. And then I'm putting my U shape. There's a union with the second interval. Now, I could keep going here to the right. I just ran out of room in that little block. So I'm going to go down below. Our next interval restarts at 6 and goes to infinity. At 6, it's a closed-in circle, so it needs a bracket. And at our infinity, it should be a parenthesis. So be careful. All right, x is every number less than or equal to negative 6. Or x can be every number greater than 7. Since this is an or compound inequality, we keep everything we ever color. We don't need to do scratch paper here because we're going to keep everything for x is less than or equal to 6, which would be a closed-in circle, and shade to negative infinity. And x is greater than 7, which will be an open circle and shade to positive infinity. The thing that's a little bit trickier here is your interval notation because we now have a union of 2 intervals. The first one starts at negative infinity and goes to negative 6, including the negative 6. Then there's a union, don't forget that U shape there, with a second interval that starts at 7 and ends at infinity. Parentheses here, not brackets, since we have an open circle at 7. All right, last one. X can be every value greater than 13, or x can be every number less than or equal to 4. My suggestion is put your less than one first because this is your lower number that's going to go here on your number line. That'll help you stay organized. So x can be every number less than or equal to 4, or it can also be every number greater than 13. All right, let's make our graph of solutions. Less than or equal to 4 would be a closed-in circle and shade to negative infinity. Greater than 13, an open circle and shade to positive infinity. All right, we have a union here of 2 intervals. One that starts at negative infinity and goes to positive 4, including the 4. And a second one that starts at 13 and goes to infinity. All right, I hope that helps you attack your graphing work for today. See you guys later.